Hello. Today I'm going to discuss the keys to logarithms, part one. Logarithms are a famously intimidating subject in mathematics. So if you've been introduced to them and you're a little scared of them, then I get it. But I'm going to make things really clear, I hope, in the next few minutes. All right, to begin, I want to acknowledge what the definition of a log is, because this is what most teachers will write on the board the first day when you look at logarithms. If a number b raised to the x is equal to m, then the log base b of m is equal to x. That's the definition of a log. To be a little clearer, I'd have to describe some of the boundaries on what b and x and m can be. B has to be a positive number that's not equal to 1. M has to be a positive number as well, but I don't think that has anything right now. This is a very confusing definition, and I doubt that it makes much sense to anybody the first time they see it. Instead, here's the main key to understanding logarithms. It's to ignore this definition at first, and instead learn this informal one, which is equivalent to this, but it's much easier to understand. The informal definition is that the log base b of m, that's how you pronounce it, and you should learn to pronounce it correctly. The log base b of m is the exponent you raise the number b to in order to get, as a result, the number m. I can't emphasize this enough. Memorize this phrase. Memorize it. What the log base b of m is an exponent that you raise that number to in order to get that number. And I want to address something that's a major misunderstanding that often young students have. There is no exponent here of m to that b. That's not what this notation means. That's not b to the power of m. It's a little b, it's a subscript b, and we're not raising b to the m. So be careful about that. And here is an example of this. What number is equal to the value of the log base 3 of 9? This is a really good example to think about it first in understanding logs. What I expect you to do is to look carefully at this informal definition and think about what it says that is. The log base 3 of 9 is the exponent. That is an exponent. That is what it is. It's a particular exponent. It's the one that you raise b to. B is the little number. It's the number you raise 3 to in order to get whatever number goes here, in this case 9. Now, this becomes a thought question. What number do you raise 3 to in order to get 9? 3 to the what is 9? The answer is 2. You square 3 to get 9. And so, log base 3 of 9 is 2, because 2 is the number, the exponent, you raise 3 to get 9. See that you cannot see that now. So if I can get that in there. There it is. That's it. That's the key to understanding logs. Now it is equivalent to this. I'd like you to notice, now that you see that this is saying that the log base b of m is the number x in this equation. Notice, that number, the log base b of m, is the x value. Look, it's the exponent that you raise b to in order to get m. It is saying that, but this is a much better way to understand it. I'll give you one more example of this in order to emphasize something. I'd like you to find the value, another example, of the log base 2 of 8. Now I'll say that some teachers actually teach kids to do something here that I think is not a good idea. What they teach you to do is to write equals x. So I think a poor method for this, so to say poor, is to write it as log base 2 of 8 equals x, and then use the definition of logs says that this to this number is equal to this number. 2 to the x is equal to 8. And then the answer is, what's the exponent you raise 2 to in order to get 8? It's 3. 2 times 2 times 2 is going to get you 8. So the answer is 3. But I think that that is a method that has to do with memorizing where certain things fit, and it's something you're going to forget. I think a better method is to memorize this phrase. Log base b of m is the exponent you raise b to in order to get m. And so, log base 2 of 8 is the exponent that you raise 2 to in order to get 8. It's just 3. And you don't have to write x in there, and it's not an equation to solve. It's a thought question. That is the main key that I'm going to share here right now. And I'll give you a part 2 where we talk a little bit about how to use this. Because I will say, at the end of this, this seems like a pointless definition when you first see it. Like, why would somebody make up this silly notation? And I'm going to show you why in the next video. Hope that helps.